Here is part 2 of lesson 73. Example 2a. Show that the integral of cotangent x dx is equal to ln of the absolute value of sine x plus c. The ln sine x prompts me to think that sine x must be somewhere in the denominator in the function that I'm trying to integrate. So I'm going to start by writing down the integral of cotangent. It's not letting me write. Okay, there we go. Cotangent x dx. And it is equal to cosine x sine x. This is good news, right? The substitution that I'm thinking is u equals to sine of x, so that du is cosine x dx, which turns my integration into 1 over u du. And we know that the result of this is ln of u plus c. I am going to write my substitution directly. And here we go. B. Hence, calculate the area bounded by y equals to cotant x, x equals to pi over 4, x equals to pi over 2, and the x-axis. Anytime we do a calculation for area, you should make sure the area is not split into a section above and a section that is below the x-axis. So let's take a quick look at this. We know that the graph of cotangent x, at 0, it has a vertical asymptote, and at pi over 2, it is 0, and it looks something like that. Pi over 4, it's halfway, so it looks safe, right? Because we are interested in this particular area here. That's good, so there's no trick. We can directly apply the area formula, which is by taking the definite integral from pi over 4 to pi over 2 of cotangent x dx. Our result from part 1 tells us that the integral itself is this. Very good. Here we're going to have ln of 1 minus ln of 1 over root 2, which means that we have ln of 1 over root 2, which is root 2. If you decide to work out this value, it is approximately equal to 0.347, rounded to 3 significant figures. Example 3. Use partial fraction to find the area bounded by the x-axis and y equals to 1 over x squared minus 4, x equals negative 1, x equals to 1. The function y equals to 1 over x squared minus 4 is a reciprocal quadratic function. If I write x squared minus 4 in factored form, that's what I get. And it shows me that a over x plus 2 plus b over x minus 2. If we recall from earlier chapters, this implies 1 must equal to a times x minus 2 plus b times x plus 2 when we try to find a partial fraction. Letting x to be negative 2. I'm going to do that first. Then I will have 1 equals to negative 2 minus 2 is negative 4, negative 4a, giving me a equals to negative 1 over 4. Now if I let x to be 2, then I will have 1 equal to a times 0 plus 4b. giving me b equals 1 over 4. Which implies that y can be written in the form of, I can actually factor out the 1 over 4. 1 over 4 of, I'm going to start with the second term, 1 over x minus 2 minus 1 over x plus 2. Okay. Another thing to note in order to answer this question is that we have to make sure the area bounded by the x-axis, the curve, and also the cutoff boundaries is on the same side of the x-axis. So let's check quickly. Let's make a sketch. I know this is not straight, but this will do. I know that this particular function, because it's a reciprocal of this quadratic, will have vertical asymptotes at x equals to -2 and x equals to 2. The graph will look something like this. Remember the funny shape? And the horizontal asymptotes, of course. Let's just do a quick review. And this. Somewhere here, because it's symmetrical. It's that weird U shape, okay? It should be more flat. And the area that we're looking for goes from -1 to 1. Good enough. Okay. So going back to the actual question, this whole area rests under the x-axis. So we know that if I take the integral from -1 to 1, it's going to give me a negative value. But in area, we always state that using positive values. So keep that in mind, okay? So the area that I'm looking for can be found by taking the definite integral from -1 to 1 of the function, absolute, 1 over 4 times 1 over x minus 2 minus x plus 2, like that. I can pull out the 1 over 4 to keep my math simpler. Now the good news is that I have two reciprocal functions, but these are reciprocal of linear functions. So from doing your homework, you may recognize that the integral of these functions is simply ln of x minus 2 minus ln of x plus 2. And we evaluate from -1 to 1. Okay, so let's see. What do we have here? I have ln of 1 minus 2, -1, but that's absolute. So ln of 1 minus ln of -1 minus 2, -3, so positive 3. That's coming from the very first ln x minus 2 absolute. Minus, here I have ln of 1 plus 2, 3, minus ln of -1 plus 2, so that's 1, like that. We shouldn't be surprised that these values are just flipped, because the area from -1 to 0 and then to 0 from 0 to 1 should be the same. What does this give me? I have ln 1 plus ln 1, but those are zeros. And I have ln 3 under the absolute. Oh, I should have an absolute, not square brackets here. Okay, so this is 1 over 4 times 2 ln 3, which is half ln 3, or I can write it as ln 3 to the power of 1/2, which is ln square root 3. Example 4. Given the function of f prime, and f of 0 equals to 4 over 3. Find f of x. We already know that the relationship between f of x and f prime is that you can take the integral of f prime to find f of x. So let's do that. Okay, I will separate the two integration because they speak of two different rules. So first, let's look at the integral of e to the power of 3x plus 1. I can let u to be 3x plus 1. du is 3 dx, which really means that if I want to replace dx in my original expression, I have to replace it with du over 3. I can rewrite it then as 1/3 integral of e to the power of u du. Minus the second integral. I don't really need a substitution because I know the integral of secant squared x is tan x plus c. Integral of e to the power of u is e to the power of u. So this is e to the power of 3x plus 1 times 1/3 minus 10x plus c. To get the actual f of x, we need to make use of f of 0 equals to 4 over 3 so that we can find a constant. So I've got 1 over 3 e to the power of 0 plus 1, so 1, or just e, minus tangent 0 plus c. This is equal to 4/3. That means tangent 0 is 0. So I have e over 3 plus c, implying that c is 4 minus e over 3. You can leave the odd number e just as is. And we can conclude that the function f of x must be 1 over 3 e 3x plus 1 minus 10x plus 4 minus e over 3. And that's it.